Good evening, everyone. Thank you for joining us and welcome to the UBC Extended Learning's info session on Intro to Systematic Program Design in Python program. I would like to begin by acknowledging that we are gathered today on the traditional, ancestral, unceded territory of the Musqueam, Squamish, and Tsleil-Waututh peoples. Let me now show you the outline of the info session for today. We will start with housekeeping tips followed by the introductions and then learn about the various aspects of the program. And after the presentation, our experts will also answer your questions during the Q&A session. Okay, so moving forward with the introductions, I am Neha Shivhare, Program Leader at UBC Extended Learning. And joining me today is Meghan Ellen, who is an Associate Professor of Teaching in the UBC Department of Computer Science. She joined UBC in 2007 and has an extensive experience teaching program design, software construction, and software engineering courses. Meghan holds a UBC certificate in curriculum and pedagogy in higher education. Before joining UBC, she worked as a software developer for a local startup company. Meghan appears in several pre-recorded videos throughout both the courses of this program. And moreover, these courses are developed and overseen by Meghan. And we are so lucky today to have her with us for this info session. We welcome you, Meghan, and thanks for taking out time to join us today. We are looking forward to hear from you. I'm wondering if you would please like to tell us a little bit about yourself.
Thank you very much for the introduction. So yes, I've been teaching at UBC for 15 years now. I've taught a number of courses based on very similar curriculum to what is available in this extended learning course to thousands of UBC undergraduate students who tend to come from a range of programs. So students from all areas of science, in arts, business, forestry, all the areas of UBC. So this two-course program through UBC Extended Learning is based on a first-year undergraduate course, like I mentioned, that's been running at UBC now for many years. So it's been worked through with thousands of students, and we've had a lot of time to revise the curriculum and make updates as we gather feedback. It's developed through or delivered through these two online courses. So there's pre-recorded videos. There are no live class meetings, but it's you can receive support from a UBC facilitator. Her name is Mariana, and she's amazing, through online office hours twice a week. And those office hours are really meant to help first familiarize you with our course and with the program, and then answer any questions that you have about assignments that you're working on, or really anything any questions you have about the course. The courses are designed for beginners. So about 1/3 of you said you had never written any code before, and you are exactly our intended audience, as are the rest of you who have written some code. So it's certainly designed for beginners. We don't assume that you have any programming experience. But of course, it's developed for adults. So we have a better sense now of where you're coming from and why you might be interested in this course, but had anticipated that it would be kind of mid-career learners, people who are maybe looking to upskill or might be considering a career transition. So by the end of the program, and by the end of the program, I mean by the end of course 2, what you'll be able to do is take a reasonably large programming problem and break it down into well-structured subproblems. And then we have processes for solving each of those subproblems. In a few slides, I'll show you an example of some past student final projects so that you can get a sense of what kind of program you would be able to write at the end of this course. you'll be able to design the representation for a reasonably complex data problem. One of you mentioned an interest in data structures. We will use a few kinds of data structures in this class, but may not be getting as deep into data structures as you're thinking. So feel free to ask more if you're wondering what kind of data structures you would learn. And a big focus of this class is that you'll learn how to write well-organized, well-documented, and well-tested Python programs. So in particular, our focus is not on the Python programming language, and it's not on Python syntax. So you certainly will learn some Python syntax, and you will be writing code in Python, but the particular programming language is more of a tool to help us learn these fundamentals of programming. So writing good tests, writing consistent code so that others can read it. Those kinds of things are the main focus of this program. So I was very pleased to see the word design come up as what you're hoping to learn, because the real focus of this is program design. So here is an example of a course 2 final project. There is a final project in course 1, but what I want to show you is if you finish both courses, what kind of program would you be able to write? Now, these programs are actually fairly long, so I couldn't fit it on the slides. So I can tell you a little bit about it and then show you some pieces of code that the students wrote. So what you would do is write a program to read some information from a file, represent it as data in your program. So by that, I mean, think about the different ways that we've learned to represent data, make some appropriate choices. And then now we have the information from the file as data that we can work with. And then you would design functions that would allow you to answer some interesting questions about the data. And those questions are really your questions. So we provide some sample information that you can choose to use. I think we have around 20 options, but you're also free to propose your own. So some people might choose something related to a hobby that they enjoy, or something related to one of their academic or work interests. So you're answering some kind of question about that data, and then designing a function to display the answer to that question or questions via a chart or graph. So for example, a histogram, a pie chart, a scatter plot. There's 5 that we teach you how to design. So as this one example project, this student chose to use information about global video game sales. And what they wanted to know was, what are the total sales for each genre of video game? So they had a CSV file with a bunch of information in it. And then the graph on the right is the end result of their program. So that was the graph that was created. And this here is just a piece of code to show you the kind of code that we write in this class. So here they were, this is how they chose to represent the sales data. So each piece of sales data, as you can see at the top, it had a genre, which were what we ended up seeing on the graph before, and then the global sales. So a lot of this won't make sense. You haven't started the class yet, but just as just kind of a preview as to what you would be able to generate. So this particular final project had, I believe, 4 data definitions, where this is an example of one data definition. So their data representation was, longer than what you can see. And then this is one of their function designs. And I believe they had 8 function designs. So again, this is just a small piece of the final code that they generated. But you can see here that they've designed a function, and it's a little bit hard to see at the bottom, but what is down at the bottom is the structured testing that students learn how to do. So not only is this the code to get the global sales for a particular genre, but it also includes the test for that. So why do we teach using Python? Python is a commonly used versatile programming language with a large community and lots of online documentation. Now, the online documentation can be challenging for beginners. I still find some of it challenging, but there's lots of online resources that you can use. And it's relevant for a lot of applications. One of our hopes in choosing Python for this course was that because it is a fairly widely used language, that it might help students who are collaborating with others. Because maybe, it depends on where you're working, but maybe the people that you work with that are doing programming in your company are using Python. So there's many roles that require programming or Python skills, and really you need to know more than just the language. So it's not about the language syntax, like I said before, but it's about learning to develop these high quality programs that are maintainable, right? When you write a program, ideally it's going to get used for a long time and then it will need to be updated. So we want to, from the very get-go, write programs that are high quality and therefore are easy to maintain, or easier to maintain. It's still work to maintain them. So that is what the key learning goal of this course, just to quickly and reliably develop high quality programs. So like I said before, this program is designed for adult learners with no background in computer science. If you have a little bit of background, the course might still be appropriate for you. If you've done a lot of programming, it might not be, and I would recommend that you ask, just so that we can try and help you gauge whether it's a good fit for you. I think the skills are really a good fit if programming would be a part of your job. So maybe you're looking to upskill. Some of you said upskill for why you're here, to add some programming skills for your current role. If you want to pursue a career in software development, so if you're thinking of a career transition, I think these courses will help you figure out whether you enjoy programming and whether it's something that you want to pursue further, and would set you up well for further courses that you would take. But these two courses alone are not going to be enough to land you a software development job. So if you think about somebody who's doing a full 4-year degree, they're taking many, many courses in computer science and software development and software engineering. And this is the beginning of that. You will gain some real world skills that you can go and use, but it's not going to put you at a place where you could go and get a full software development job. So these courses, as you might know, are part-time and 100% online. The weekly modules are self-paced, and we try to offer quite a bit of flexibility in when you complete the modules. We know that you all have a lot of other things going on in your lives, and some weeks you may be unexpectedly unable to complete the modules. So each course has a 1-week break in the middle where you could either take a break or you could catch up on the previous modules. We do release the modules at a rate of about 1 per week or 1 every 2 weeks, but we know that some people, things come up and they end up working through the modules later, and that's fine. Our course facilitator is able to help you at whatever stage that you're at. If necessary, we sometimes offer extensions at the end of the course if people are trying to finish them and weren't able to complete them by the stated end date of the program. So each module has some pre-recorded videos, some readings, they're relatively short, but some readings, auto-graded questions, and practice problems. With one of the practice problems in each module, we ask you to self-assess your design. So give you some guided questions that can help you look at what you've completed and help you gauge whether you're fully understanding or maybe whether you need to keep asking some questions about that material. Each course offers 2 facilitator graded assessments, and that's new as of this fall. So midway through, there'll be an assessment where a facilitator will give you feedback on your work, and then both courses offer a final project. The virtual office hours are optional, but if you can make them, they're highly recommended. It's a great chance to chat with Mariana, our course facilitator, and also with other students and ask questions and see what kinds of questions other students are asking. We also have an online discussion forum where you can ask and answer questions at any time of the day. It tends to take us about a day ish to respond to those, a day or two. But that's a place where you can also answer questions of your peers, or they can answer your questions as well. As this is a 2-course sequence, the first course is a prerequisite to the part 2 course, and you must achieve 70% in part 1 to advance to the next course. Both of the courses are planned for 9 weeks with that 1-week break in the middle. And our estimate is about 80 hours to complete each course. Now, of course, that varies by the students, but that's our best guess as kind of an average amount of time that it might take. The first part of the course is introducing what I like to describe as the foundational pieces for this approach. So the first module is an introduction to Python. It's a very brief introduction to a very big programming language. So we take the approach that we're trying to just teach you a little bit of Python, and then we introduce more pieces of the language as we go. But even by the end, we're only using a very, very small subset of Python. So again, we're not focusing on learning the language, but instead we're just using the language features to support the learning goals of the course. Sometimes that first module can feel a little bit overwhelming because it's all of this new Python at once. But just trust that we've done this with lots of students, and we know that it can feel like a lot. But as you practice, those language constructs will start to become more familiar. Then the next modules in part 1 are introducing those systematic design processes that you'll then continue to use for the rest of the course. So by the end of course 1, you're able to design functions and design data definitions, which is how we represent data. And then when we get to part 2, it's more advanced program design skills. So we start by looking at how to decompose a function into smaller sub-functions with a goal of having each function accomplish exactly one task. That helps keeps our programs organized. It helps keeps our programs easy to maintain and easier to read. Then we learn the kind of the biggest systematic process in our course, which is how to design a program that will allow us to complete that project. So for that, we start off by some planning steps. What information do we have? What question are we interested in answering? How do we want to answer that question? And then we get into actually building the program. So a lot of what we do in this class is really trying to take those careful steps to do things neatly the first time. I sometimes like to use the analogy of house maintenance. If we start off with our house well designed and well constructed and keep up doing good maintenance, it's always going to be easier to maintain and cheaper in the long run and all of those things. The same is with programs. If we start with a good plan and we do a good job of writing it and we maintain it, everything's easier and smoother and less frustrating. So then by the end, the last module is learning how to create those graphs and charts so that we can bring it all together and do a project like I showed you earlier. So your work is assessed in each course by comprehension checks. So those are auto-graded questions in each module. Self-assessments, which are graded for participation. So it's not about whether you've correctly assessed your code, it's really about the exercise. So we want you to engage with those assessments and really use them to help yourself understand, am I comfortable with what I learned in this module, or should I go back and keep working? And then a midpoint facilitator graded assignment and a final project, which is graded by the course facilitator as well. As we discussed, the next 2 offerings of part 1 start on September 6th and January 10th. And the next 2 offerings of part 2 start on November 15th and March 28th. And as you can see, we have a winter break. I think that's about 3 weeks, from December 20th until January 9th. So that's why those dates look a lot longer. It's still the same number of weeks of the course, but we take a break from sort of mid-December until the early January again. And you can see the program fee for each course, and then there's a bundle fee if you register for both courses. So that is my description of the course, and I'll pass it back for a Q&A session so you can ask any questions that you have about the courses.
Thank you so much, Megan. That was such an informative presentation. And now moving forward with the Q&A session, I will start sharing my screen. Okay, I'll read this one. What is the difference between well-constructed Python language program versus other object-oriented programming languages program?
That's a good question. So first, let me say, for those of you, if you haven't heard the term object-oriented programming, that's totally fine. Python you can write object-oriented code in Python. We don't get to objects in this class. So if you've heard that term, that's not something that we learn in this class. And what's the difference between well-constructed Python code versus other code? I think that's a great question. What we're really learning here is a foundational approach to programming that can be used in any language. So, for example, the particular syntax that we use to write tests is only relevant to this course. Like, we have a course-specific library that we use in order to allow us to write tests in a very particular way. So the syntax is specific to this course. But what we learn about testing, so for example, that we should write tests, what kind of test cases do we want to include? Why is it important to write tests? All of that will generalize to any language. Now, when we're thinking about a particular language and writing well-constructed or well-designed programs in that language, it also depends on the particular conventions of that language. So just like natural spoken languages, I'm monolingual. I speak only the tiniest bit of French, but if any of you are bi or multilingual, you might express things differently in different languages based on conventions or customs, that kind of thing. So certainly there might be some kind of Pythonic ways of doing things that don't transfer, and you would, if you pick up another language, you would learn those particularities of the other language at that time.
Thank you, Megan. The second question is, are these credit-based courses?
So these courses, you can maybe help me out. So I believe you receive a certificate of completion from UBC Extended Learning, but they aren't credit-based courses for UBC undergraduate degree.
Exactly. Okay, let's move on to the next question then. Is it possible to skip the first course and do the second course only?
Generally, no. So the second course very much depends on what you learn in the first course. So the first course I like to describe as the foundational building blocks of what we need for the rest of the course, for the second course, I guess. And so it's not possible to skip the first one and do the second one. If there was an unusual situation, like somebody had taken part of that course offered as a credit course at UBC or in extended learning, then you could reach out. But in general, the answer is no. You have to do course 1 before course 2.
Mm-hmm. Okay. So the next question is, my background is in engineering and wrote code 30 years ago. I'm now in finance and use Excel, some VBA, but thought Python would help. Is this the course for me?
That is a good question. And even though you've given some very helpful context, I feel like I might need to have a longer discussion with you to really help you figure out if this is for you. I think if it's been 30 years since you've written some code, it sounds like you write still some Visual Basic. It's possible that this could be a good fit. And if you want to have a quick Zoom meeting, you can find my email address online, send me an email, and I'd be happy to have a quick chat with you and get a little bit more information and try and help you figure out if this is a good space for you.
Okay, the next question is, when is the deadline to apply for the first course starting next week?
I believe that students are usually able to register even in the first few days after the course starts. So is there a firm deadline? I'm not sure.
They can still apply for this course. Yeah, as you mentioned, Megan, we would be flexible. Yeah, thank you. Would you recommend someone who has completed the key capabilities in data science from UBC Extended Learning to take this course?
I think that's another one where we might need to have a quick conversation and see what your goals are. So I have some familiarity with the key capabilities in data science program, and there's certainly some overlap. Like I know the main focus of our program is about writing these well-designed, well-structured, well-tested programs, and they certainly encourage that as well, with a focus on data science. So much more of their course is about data science, and ours is on those kind of foundational programming pieces. So again, I would say reach out and we can have a quick chat and I can help you figure out if this course might help fit your goals.
Okay, and what system requirements do we require?
Probably any computer would be fine. So we give you access to a web-based programming environment. So you need a browser. Any computer probably within the last that's been purchased within the last 4-ish years would be sufficient. We do provide instructions if you'd like to download an application so that you can program if you didn't have access to the internet. So you can do that as well, but that's not required. So really any system works. I have seen students do this course on iPads. I think that unless you have an external keyboard, that might be frustrating. And I type on my iPad like this, but I have seen students do it.
Okay. And why should I choose UBC Python intro courses and not Coursera or Udemy courses?
That's a great question too. And I think it very much depends on your goals. So there's so many Python courses online. I don't know which ones you're referring to, so I can't kind of compare and contrast against a particular course. I think some of the courses online tend to focus more on the syntax of programming, which some people are looking for. But these courses really get to the foundational aspects of how to be a good programmer. So for example, when we're designing a function, we don't just start writing code. First, we think about what's the input type and what's the output type. And then we write that down. And then we move on and we think about what are some examples? Like what kinds of inputs would this function take and what would I expect it to produce? So this really systematic process. And because this is a course, as a pedagogical tool, we have what we call a recipe and steps that you must follow. And once you finish this course, I think most people wouldn't sit there with their recipe and follow it in the same way that's mandated within the course. But I really do think that process of thinking about the input and output types, thinking about examples, thinking about the form that the function might take before we start to write the code, all of that I think is foundational and will really help you moving forward. So that's only sort of an answer given that I don't know exactly what other courses you're considering, but to me, that's what I think is really important about what you would learn in this class.
Thank you, Megan. The next question is, do you recommend this program to someone who has many years of experience in development? If not, what other courses, for example, like upper levels, UBC is offering?
So I think as a general answer, I think no, I would not recommend this course to somebody who has many years of development experience. Depending on that experience, like again, if you'd like to reach out and tell me more about the work that you've done, I could provide a more comprehensive answer. But I think many years of development experience, this is probably not the course for you. What other courses are UBC offering? As far as I know, there aren't other courses in upper level through UBC Extended Learning. One thing that the computer science department offers is a second degree program. So if you have a previous degree and are interested in more upper level UBC courses, UBC has the Bachelor of Computer Science degree, which is a 20-month program. Many students take 24 months or a little bit longer if they do a co-op program and work while they're interleaved semesters when they're going to school. But I think that might be an option that would be a better fit for you if you're looking for upper year material.
Thank you. The next question is, what courses I should take after SPD1 and SPD2 to continue learning systematic program design, and how to apply it to object-oriented solutions?
That is a great question too. And unfortunately, I don't know of a particular course that I would suggest for you to take next. As I mentioned, there are a lot of options online. So it's possible that you would find something that's a good fit, but I'm also willing, if you take the program and complete, I would be willing to have a conversation at the end to try and help you figure out where you might want to go next based on your goals. I think everybody has such different goals for what they might want to get out of it. It's hard for us to come up with one particular recommendation for what you might want to take next.
So if you have more questions or if anything else comes to your mind, you can always contact us at info.exl@ubc.ca, and the phone number is 604-822-1444. And with that, it seems we can start wrapping up our info session for today. Thank you so much, Megan, for your presentation and for clarifying all the doubts. And thanks to all the participants for their enthusiasm during this info session. We will now end this info session, and I would encourage you to visit the program website for further details. Thank you very much, everyone, for your time and patience, and we look forward to seeing you all in the course. Have a great evening. Thank you.